Welcome to video 5 in our course on metagenome classification. We're going to look at DPR finder as one example of how we can approach this. So this method is trying to predict viral sequences, hence the name. It uses CNNs, convolutional neural networks, and it needs information initially to identify what our viral sequences are most likely to look at. So it needs training data to develop CNNs to predict what viral sequences should look like. So we use our appropriate viral database for that. So it depends again what you're looking at, because viruses can be quite diverse. So a bit like looking at motif structures, it creates position weight matrix that we have, of which we have a particular length, and we might have 4 dimensions to that. And like typical motifs, we have a probability of having a base at particular site. So most sites are highly conserved, but some sites have some variation. So what this kind of does, it has initial databases that are input, can encode them in the 6-frame translation, it uses CNNs to identify ones that are most likely to be viral, using these steps rectification pooling to predict the most likely outcome at the end. One thing with these approaches is obviously it needs a lot of good training data, or else it'll be very noisy. So what we'll need to do is have a FASTA file of context that are representative of our data set, and our output will be a predicted score of p-value for each of the contexts that are of interest. The p-value is typically from a null distribution for prokaryotic genomes, so it tries to predict contrast our prediction for the viruses against that null distribution. And if we wanted to make our own data set, we would create 4 data sets, one for the host and viruses for training, and one for the host and viruses for data validation. And you can follow this GitHub link for more. So that concludes this video. Please see more to continue this course.